Now this time we start with the following question on counting multiples. How many positive integers less than 101 are multiples of 9, 4, or 5? Well, to answer this question, let's just come up with some notation first. So let us denote the multiples of I in the range from 1 to 100, right? Less than 101 by mi. Well, so what is that we're trying to count? Well, we're trying to count the following. So we want to know the cardinality of the following set. Now that we have this notation, we have M9 union M4 union M5. Well, but principle of inclusion-exclusion, right? I separate them in individuals. The cardinality of M9 plus the cardinality of M4 plus the cardinality of M5. And I would finish with this count if these two had nothing in common, but they do. So I have to discount. So I have to discount what is common to this and this and that, and among these two. In other words, I have to discount the cardinality of M9 intersection with M4, the cardinality of M9 intersection with M5, and the cardinality of M4 intersection with M5. Then you may say, well, but there are three sets involved. We have to put back things that are common now to all three, right? And I agree. We would say something like this: plus the cardinality of M9 intersection with M4 intersection with M5. But now, just something basic. When you want to know the cardinalities in this case, right, of Mi intersection with Mj, well, what is this? Well, this is nothing else but the multiples, right? So the ones that are multiples of I and multiples of j in this range are nothing else but the multiples of the least common multiple of I and j. Well, similarly, for three elements, if you intersect 3, it's just the least common multiple of all those 3. Okay, so now, keeping this in mind, the computation that we just have now, well, might be described in the following terms. Instead of writing all of this, and then I can use, and I'll put it all together, that's fine. We have M9 plus M4 plus M5, and then minus, well, minus what? Well, the least common multiple of 9 and 4 is 36. The least common multiple of 9 and 5 is 45. The least common multiple of 4 and 5, well, is 20. And of course, is the subtraction of all of this. And you will say plus, well, the cardinality of all the multiples of the product of the 3. I mean, why the product of the 3? Because these 3 are all coprime, right? They have no common factors. So we would say that this is, well, 180. But then now it's just a matter of counting. Because what is this? Well, I'll compute, right? What are the multiples of 9 in this range? Well, simple division, computing the floor of that fraction, plus the floor of this fraction, plus the floor of this other fraction. And to that I subtract, well, the floor of this fraction along with the floor of this fraction along with the floor of this fraction. And finally, well, I incorporate back the floor of this one. Let's make a summary, right? An arithmetic summary. It would be 11 plus 25 plus 20 minus 2 plus 2 plus 5 plus 0. And then, well, whatever that number is. What really is important is the decomposition. Yeah. See you next time.